Yesterday we are discussing ammeter bias circuit. Okay, let us do one more problem. So you have power supply. Okay. You have transistor. And this is your ammeter bias. Okay, you have RC, you have RB. RB is connected directly to base, and the power supply is given 15 volt VCC. Okay, and beta in this particular question is 100. Okay, VB is given 0.7 volt. Okay, so you need to find the operating point. Okay, so RB and RC value is given 100 kilo ohm and 900 ohm. 900 ohm, and this is your 100 kilo ohm. Okay, so method is same. Okay,
Sir, recording.
recording run हो रहा है recording एक जगह हो रहा है. Okay, so you have input loop. Okay, so input loop, apply KVL. So you have 15 volt. Okay, 100 kilo ohm. So obviously this current is IC, and this current is your IB. So minus 15.
Max आवाज आ रही है.
Max से आवाज आ रही है.
Yes sir. अब ठीक है सर.
ठीक, okay. So minus 15 volt. Okay, 100 kilo ohm into IB plus 0.7 volt. Okay, plus here I current is flowing. That is I is your beta plus 1 IB. So I can write here beta plus IB. Beta is 100. So 100 IB 100 ohm. RE value is 100 ohm. Okay, so what become this one? IB is beta plus 1 RE. Okay, so 101 into 100 into IB. Okay, now I want IB. So IB is your 15 volt minus 0.7, and then you have this 100 kilo ohm here. Okay, plus 101 into 100. Okay, so if you solve this one, this will give me what, 14.3, and this is 100 kilo ohm, and this is how much kilo ohm? 101 into 100. Okay, so this is 100 and this is your 10 kilo ohm. Okay, they're 10.1 kilo ohm. Okay, I can write 10.1 kilo ohm here. So this become 1110.1 kilo ohm. Okay, so this come, so divide 14 by 3 by 110.1. Okay, so what value should give? So what I'm getting 0.12 milliampere. Okay, please check whether you're getting this one.
Yes sir.
Okay, so this is a microampere, 129 microampere. Okay, if you want to write, you can write in microampere. So now you know the IB. Okay, IC will be obviously your beta IB. So 100 into this. So this become IC become your 100 into 0.12. Okay, milliampere. That is your 12.9 milliampere. Okay, now you can calculate IC saturation to check whether it is a saturation. So you check IC saturation. So IC saturation, you have to make VC 0. So once you make VC 0, your IC saturation will be VCC 15 divided by RC plus RE. Okay, so that will become 1000 ohm. Okay, so this will give you 15 milliampere. So my IC is less than IC saturation. Okay, so the operation region will be active. Okay. Now you can find VC value. Okay. So VCE is nothing. VCC minus, this time you have ICRC, no? You have VCE minus IC, and what should I write? IC, can I write ICRC? Okay, so let me write up an equation, then you will do approximation. So you have VCC minus ICRC plus IERE. Okay, now here I can take IE almost equal to IC, so I can add VC minus RC plus RE equals to IC. Okay, so from here I can find the value of VC. VC will be 15 minus, this become 1000 into RC IC was 12.9 milliampere. It's cancelled, so you have 13, so you have 2.1 volt. Okay, so the operating point Q is your 2.1 into 12.9 milliampere, your IC value. So in transistor, calculations are very easy. Okay, you just need to follow the loop and properly apply the KVL. Okay, keeping in mind the signs of voltage. So other things are very easy. Just check it is correct or not. Okay. If you want correctly, you can put IE value also, no issue. You know IC, you know IB. You can put IE, even here you know to do approximation also. You can put IE value, IC plus IB, RE, you know. So this will slightly come less. It will come 2 volts. Okay. So I hope this method is clear. Now we will do some biasing, which is used in practical applications. Okay, which is more practical. Okay, which will keep your Q point in active region. Okay, so let us do very important biasing. जिस पे क्वेश्चन एग्जाम में आते हैं, voltage divider bias. Okay, voltage divider bias. Okay, so voltage divider bias. Okay, so we'll do first approximation method. Okay, so let me first do what is your voltage divide biasing. So you have a transistor. Okay, you have VCC, you have a resistance RC. Okay, and here you have two resistance. Okay, say R1, and you have second resistance R2. Okay, and of course you can keep this ammeter biasing also, RE also you can keep. Okay, so this is your voltage divider bias, because here voltage is getting divided here. Okay, this is your point VB. Okay, so now this solving this circuit, okay, or this type of biasing, we will use first approximation method, which approximation means this is almost same value that will give, but it is little bit faster. Okay, so you can use this technique also. Only there will be some slight approximation value, okay, of when we calculate the operating point. So suppose here I'm giving a VCC. Okay, so of course this current here going, that is IC, and this current here going, this I. Okay, now and here this current is IB. So I current is coming and I current is IB is going, remaining current is going here on R2. Now इसमें approximation क्या है? Approximation ये है कि हमको पता ही है that this IB is very less. Okay, always IB is negligible. This is microampere. As soon as current turn this side, here we have diode. Okay, that voltage is fixed 0.7. So this current becomes very small. This is in microampere, negligible. So what I can do as an approximation, just for approximation, okay, in reality some value is there, I take this as a 0. Okay, IB equals to 0. So approximation is what? Approximation is your that you take IB almost equals to 0 because it is in microampere. So once IB is 0, okay, there's some solving. Okay, and then all the currents, I current is coming here, that will go here, then go here. Okay, so you get voltage say V1 here, and you get some voltage V2 here, isn't it? Okay, now this voltage is V2, this voltage is V1. Okay, so now V2 is equal to VB. So if we want the VB is this potential of this point. The potential this point is equal to V2, and you can easily calculate V2. V2 is nothing, your VCC, total resistance R1 upon R2, okay, multiply by R2. This is your VB. It is point clear? Now this is very faster method to solve voltage divider bias. So automatically VC is coming. If I apply KVL here, no current is going here. So I current going here, I current here. So whatever voltage VC is there, that is dividing in these two resistors. Okay, and voltage across R2 is equal to my VB. Okay, now I know the VB. Now once I know the VB, then the things become very simple. I know my VB is what? VBE. VB is nothing, VB minus VE. Okay, VB value I know what is 0.7 or 0.3, whatever will be given. Now from here I can find my V value will be VB minus VBE. Okay, and this value is almost constant, always constant. Okay, this value you can calculate by this equation. Okay, so once you know the VB, automatically you know the V. Okay, and once you know the V, okay, you can find, you know, VE. This is the E terminal. Okay, this is a base terminal, this is collector terminal. So once you know this potential here VE, okay, automatically you can calculate almost VE. V is equals to what? I equals to V upon RE. Okay, and once you know the IE, I is equal to your IC. So you can, so easily you can calculate your operating point. Once you know the IC, you can find here VC. So this is very fast technique. Okay, but slight approximation is there. Now you can you can do back calculation of IB also. Once you know the IE, you can find IB also. IB will be your IC upon beta. Okay, now when this method should be used, okay, so you can use this method when IB critical. You have calculated IB from here. IB critical is called I upon 20. Okay, when your IB is less than I by 20. Okay, so when your current, suppose this current is coming and this IB which is going here, that is 1 by 20 times of I. Okay, in that situation you can say this method is correct, approximately correct. Okay, and it will be always, because the circuit's resistance is always given like this. You can always apply this approximation method. So the total current, what total current is coming from here. Okay, and if I by 20, the current which is going here, if less than I by 20 of this current, then you can assume that this current is negligible. You can assume it is 0, and then you can apply this method, and very quickly you can find the operating point and region of operation. Okay. So if you have any doubt, please ask this. Ask. This is very important. Are you getting what I'm doing here? Okay. VCC I know, voltage division I know. Automatically I know this VB. Once this VB known, VB is equal to your VBE, and this voltage only going here. VB and VE. Okay. So you know VB equal to VB minus VE. So you know VB, you know VB, you can find VE. Once you know the VE, VE divided by RE is your ammeter current. Once you know the ammeter current, your IC is almost equal to IC. And you can also back do bell calculation of IB, IC, and you can recheck whatever your I is there. I is what? I is basically what? Your VCC upon R1 plus R2. So you can compare this I with this IB, and if it is less than 1 by I by 20, then you can say this method is approximation what I assume is correct. Okay. So let me do one problem based on this method. Suppose you have been given R1 value is equals to 10 kilo ohm. Okay. And R2 value 2.2 kilo ohm. Okay. RC value 3.6 kilo ohm, and RE value 1 kilo ohm. RE value 1 kilo ohm, and you have been given beta is equals to 150. So this is given. Okay. Now you can quickly solve the circuit. You can find what is IC in the circuit. Okay.
So VCC and VB.
VCC value is 10 volt. 10 volt. 10 volt. Okay. VB you have to calculate. Okay. You know, so you can find, you assume IB is 0. So your total I current will be what? VCC 10 upon R1 plus R2, that is 10 kilo ohm, and 2.2 kilo ohm, 10 kilo ohm plus 2.2 kilo ohm. Okay. And this will be what? 10 upon, okay, this become how much? 12.2 kilo ohm. 12.2 kilo ohm. So this will give you I value. Okay. How much ampere is coming? So it's coming 0.819 milliampere. 10 upon 12.2, 0.819 milliampere. Okay. That is 819 microampere. Check it. सही है क्या? 10 divided by 12.2. Okay. So once you know I, okay, you can find V2, which is equal to VB. So you want V2. So V2 is your what? I into R2. I into R2. I is known to you. Okay, 0.189 milliampere. R2 is 2.2 kilo ohm. 2.2 kilo ohm. This cancel. Okay, so this will give you VB value 1.801 volt. 1.801 volt. Check it. Coming or not? 2.2 into 0.8. Okay, so it should come around 1.8. Okay, so now you know this VB. Now what is the next step? What is the next step?
VB.
Okay, so once you know VB, you can find VE. Okay, B is nothing, your VB minus VB. Okay. So take VB equals to 0.7. So you have 1.801 minus 0.7. Okay, this will give you what? 1.1 volt. 1.101 volt. Okay, this is your VE value. Once you know this VE, you can find easily IE. Okay, you remember this I value. So once you know the VE value, you can find IE. IE is your 1.101 volt divided by RE value was 1 kilo ohm. Okay, 1 kilo ohm. This was 1 kilo ohm. So this is 1 kilo ohm. So I automatically become 1.101 milliampere, because here you have a kilo ohm. So this become milliampere, and you can assume this is also almost equal to your IC. Okay. Now you know the IC, and beta in the question is given 150. Beta in the question is given 150. Okay. So you can do back calculation of IB. IB will be your 1.101 milliampere. Okay, divide by 150. Okay. So what is this value? This
7
is your
microampere.
how much?
7.3.
7.3 microampere. Okay. So, and what was the actual I value? 819 microampere. Huh? Correct. I. So if you divide this by 20, if you divide by, you make I 20. Okay. Still, this is greater than this IB, isn't it? This will be around 40, almost I by 20. So how much? Almost 40 microampere, and that is also greater than this IB. So your approximation method is correct. Okay, you can go with this solution.
सर ये डिवाइडेड बाय 20 क्यों?
चेक करने के लिए ना कि ये जो IB हमने यहाँ पे नेगेटिव माना ना, वो इस I का I by 20 से कम है कि नहीं है, वो एक लिमिट, क्रिटिकल लिमिट रख दी है कंपेयर करने के लिए। हम जीरो मान रहे हैं और जीरो नहीं हो तो
सर 20 हमें कैसे मिला सर वो वैल्यू?
20
हाँ सर
20 एक लिमिट है 5%। 5% की लिमिट है। Assuming
ओके सर
if this current is 5%, if the current which is going here is 5% of this one, that's why 20. Okay,
ओके सर
so 5%
सो
error
हमेशा 20
we
से
are,
डिवाइड करना है?
हाँ हमेशा करना है 5% के लिए। ठीक है, चेक करने के लिए।
ओके
5 if
सर
this is 5% से कम है तो हमारा कैलकुलेशन is we can
ओके
take
सर
approximate. That's why this is approximate method. No? Now you know IC, you know IB, you can find your VCE also. Okay, so find VCE. Now how to find VCE?
4.9935.
VC 4.9, yeah, 945, yes, correct, good. So you can find, very good. So you can use the same method for VCE. Now otherwise there is one more simple method. Now this time you know this VE, okay, and you know this ICRC, so you can calculate what is VC, isn't it? What is VC? VC is nothing. VC is just VCC minus, I'm only calculating VC, this 10 volt and this is consumed, and you're getting here. Okay, so you can, in this particular question, okay, you can write VC minus IC RC, because this is I'm calculating potential of VC, not VCE. So VC I know, so VCC will be how much? VCC is your 10 volt. Okay, RC is your, how much is given? RC question, RC was your 3.6 kilo ohm. 3.6 kilo ohm. Okay, and IC just now we have calculated, it was 1.1 milliampere, 1.1 milliampere, 1.101 milliampere. Okay, so that is 10 to the power minus 3. This cancel. Okay, so this is almost 3, how much? 3.6. So VC will come how much? 10 minus 6 point
4.
4 volt, almost. Okay, I'm doing rough calculation. You can do full calculation. 6.4 volt almost. Okay, now you know V also, so you know VCE. So VC is nothing. VC is just VC minus VE. So VC is your 6.4 volt, and just now you have calculated your this one V was how much? 1.1 volt.
101.
Okay, now you do calculation, so this should come around 5.96 or how much? 4.4 point, 6.04 minus 1.1, 4.9 volt. Okay, so this is coming your कितना आएगा बताओ?
5.299.
5.29 is how it's coming. If you do
6.39.
6
4.93 volt.
4.94 आना चाहिए, 4 point something. This is 6.04 ना, this is not 6.
4.93
This is 6.04 ना.
Yes,
This is
sir.
not 6.04. Okay. Now your 4. I am taking the approximately 4.93 or 4.94. Okay, volt. Okay, VC. So now you have VC. You know the operating point. Okay. Any doubt in this method? Okay. So let us. Now this was the approximate method. Okay. Now we'll do method which is accurate for same type of circuit. What is the accurate method? Okay. Now put the accurate method. Accurate method. Now accurate method. Okay, you have to exactly, now this time you cannot take IB0, so you have to find the IB value. Okay, so this circuit, okay, I can redraw again. So I have this VCC and RC is coming here. Okay, and RE is coming here. Okay, and I can, what I can do, I can put VCC, this VCC again here. So I have this R1, R1, R2, R1, R2, and I'm taking this VCC here. This is VCC. Can I do like this? Can I do like this?
Yes, sir.
2 VCC.
हाँ, 2 VCC मतलब सॉल्यूशन के लिए भी लगाओ, भी जो VCC लगा हुआ है वो इस पोर्शन को भी करंट दे रहा है, इस पोर्शन को भी करंट दे रहा है. ठीक है. If I calculate what is the voltage here voltage VC and here voltage VC, they both have same potential, so I can make short. Are you getting? तो जोड़ने का मतलब क्या है? भाई ये इसका पोटेंशियल यहाँ पे हाँ बोलो. हाँ,
आरई तो ग्राउंडेड है.
क्या?
आरई टर्मिनल आपने ग्राउंडेड कर दिया.
हाँ नहीं, आरई तो ग्राउंडेड है ना. आरई तो सेकंड में ग्राउंडेड ही है ऑलरेडी. हाँ, उससे क्या होता है? ये सब तो ग्राउंडेड ही है. ये तो एक ही चीज है. यहाँ पे भी तो ग्राउंड ही था. ये तो सब ये तो ऑलरेडी ग्राउंड है. इसको ऐसे कर लो और क्या, ये ग्राउंड ही था. R1 R2 ये तो यहीं से कनेक्टेड है, ग्राउंड से तो कनेक्टेड है.
सर फिर दूसरा VCC
same-
लगाने का क्या प्रॉफिट है?
अरे सिंप्लीफिकेशन के लिए आप चाहो तो एक ही रहने दो. बात एक ही, वो एक ही है. वो VCC यहाँ भी दे रहा है, वो VCC यही आ रहा है. ओके, चाहो तो उसको शो करने के लिए VCC यही रहने दो. ओके, वो एक ही VCC है. भी यहाँ से जो पोटेंशियल सेम तो है. ये पोटेंशियल मैं इसको वापस जोड़ सकता हूँ यहाँ पे. आप चाहो तो यहाँ इसको रहने दो. अब मैं क्या बताना चाह रहा हूँ उसको समझो, तो आप चाहो तो वापस लगा देना उसको. ठीक है. नाउ व्हाट आई एम ट्राइंग टू से, This time I don't know what is VB because IB is going. Okay. So what I'll do, I'll do Thevenin circuit. I will cut this circuit from here. I will cut this circuit here. Okay. And I'll find out what is the open circuit voltage here. Once I know the open circuit voltage here, I know the IB, VB, isn't it? I can find this. I can make it this is disconnected. Okay. Now I will find what is the open circuit voltage here. That is V Thevenin. I can find V Thevenin here, R Thevenin here. So that means basically I am trying to make a equivalent circuit of this one. Okay. So what circuit is coming here, here. Ultimately in this method, I need this VB. Okay. So I want to find out what is the open circuit voltage at this point. Okay. Here. And once I know the circuit, then I can find what is my current IB. So basically I'll use now Thevenin's theorem, okay, to find out open circuit voltage across R2. Okay, so that open circuit voltage across R2 is my equals to V Thevenin. Okay, what is the value of V Thevenin? What is the value here R2? Tell me. It's like same. What is V2? What is V2 value here? What is the V2 value here? Open circuit voltage कितना है?
R2 by R1 plus R2.
सेम थिंग ना, वही फॉर्मूला सेम ही है. VCC, okay, R1 plus R2 into R2. This is my V open, which is equal to V2 equals to V Thevenin. Now what is the R Thevenin for this circuit? What is the R Thevenin value for this circuit? So R Thevenin, what we do generally, I am basically making equivalent circuit of this one. Okay, with I'm Thevenin circuit, Thevenin theorem. So Thevenin theorem, I need open circuit voltage and I need R Thevenin here. So in order to make R Thevenin, I'll make this short. So once you make this short, this resistance and this resistance become parallel. So you have R Thevenin equals to R1, R2, R1 plus R2. Okay. So that means now this circuit I can simplify. This circuit I can simplify like you have V Thevenin. Okay. V Thevenin and you have R Thevenin. Okay. And then you have transistor coming here, which is like this. You have here VCC, RC, and this connected to your here, and here you have one resistance already. This you can make ground, and this is your already grounded. This is your RE. Here IE current is flowing. Here IB current is flowing. Here your IC current is flowing. The circuit becomes now simplified. So basically, I am because of this volt battery, I am calculating what is the open circuit voltage here. Open circuit voltage. Okay. So open circuit voltage is your V Thevenin, and what is the R Thevenin here? So in order to make R Thevenin, I have to make this is ground. I made this ground. So once you make this ground and this is ground, so ground to ground, you have resistance R1 R2. So one terminal is common ground, another terminal they connected. That means they are parallel. So R Thevenin is your R1 plus R2. Okay. If anybody has any confusion, please ask. Is this method clear?
Yes, sir.
Okay. So what I'm trying, I am calculating because of the VC, what is the output voltage here? That is your V Thevenin. Again, I'm making this ground. Once I make this ground, okay, then R Thevenin will be your R1, R2. Okay. So I know R Thevenin. Now I know your V Thevenin, and then I have made this circuit simple. Now this circuit you have to solve. Okay. So now you want what? You have to apply here V Thevenin. So you have minus V Thevenin plus IB R Thevenin plus here you have VBE. Okay, VBE, and you have similarly here IE, which is equals to beta plus 1 IB. Okay, so you put here beta plus 1 IB equals to 0, and then you want IB. So your IB will be simply V Thevenin minus VBE upon R Thevenin plus beta 1 plus 1 into obviously RE should be there. RE beta plus 1 RE IB beta 1 plus RE. Okay, this is your IB formula this time. Okay, and once you know your IB, okay, you can find IC. Beta will be given in the question. If beta is given, okay, you can find IC using beta IB, like same method. Okay, once you know the IC, you can find VC using VCC minus RC plus RE IC, or you can write this is also VCC minus IC RC minus IE RE. Okay, I you know IB plus IC, IC you know IB you know, you can write IB plus IC also. So whatever you want, you can solve it. So any confusion? Rest method is same. You have to find IC saturation, you have to compare, and you have to calculate. Okay, so solving your transistor is very easy. Okay, up to this is things are moving very smoothly. So your values are very very simple. Okay, so let me give him one problem, and then we'll do exam problems. So VCC is given your 10 volt. VCC is given 10 volt. Okay, R1 R2 is given, R1 is given 10 kilo ohm. Okay, R2 is given 1 kilo ohm, and RC is given 2 kilo ohm, and then RE is given 200 ohm. Okay, this is given. Find out operating point using accurate method, and beta is 100. Beta is 100. So most of your problem of exam basically comes on voltage divider circuit. 5 marks problems. Okay, and here you can take VBE 0.3. VBE 0.3 volt. Tell me what are the values? So this is given 10 kilo ohm. This is your 1 kilo ohm. Okay, RC is 2 kilo ohm, and RE is 200 ohm. So let us solve. First, we need to find V Thevenin. V Thevenin is nothing. V Thevenin is your how much? Open circuit 10 upon 11, 1 kilo ohm plus 10 kilo ohm. Okay, so this is into 1 kilo ohm. So 10 upon 11, how much is coming?
9.09 volt.
9 आएगा.
0.909.
हाँ, 0.9.
0.909.
0.909 volt is your VThevenin. R Thevenin is your R1 R2 R1 R2 R1 plus R2. Okay, so 1 into 10 kilo ohm. Okay,
तो 0.909 किलो ओम
और ये क्या आपका 11 हाँ, ये तो 6 हो जाएगा और ये हो जाएगा आपका 1.11 किलो ओम. सो ये कट जाएगा किलो ओम. ओके, सो 10.11 0.909
किलो ओम.
किलो ओम. वेरी गुड. ओके, तो बस आपको सर्किट तो सिंपल हो गया. नाउ यू कैन अप्लाई this circuit. Okay, so you have now a circuit, you have a transistor like this. Okay, 2 kilo ohm VCC 10 volt. You have V Thevenin battery 0.90 volt. Okay, and RB is also 0.90 ohm kilo ohm. Okay, this is grounded. Here RE is your 2 kilo ohm. 220 है 200 ohm. 200 ohm. 200 ohm. Okay, this is your 0.3 this time. So you can find what is the value of IB, what is the value of IC. Beta is already given in the question. 100 दिया था मैंने आपको. 100. Beta is 100. Okay, so your IB will be VThevenin 0.90 volt minus 0.3. Okay, और क्या था 0.909 kilo ohm, that is 1000 ohm, and you have a beta plus 1. Beta plus 1 is your 101 into RE. तो 0.2 kilo ohm बोल दो इसको. 200 ohm है तो. Okay, now you can solve and tell me what is your IB.
Sir, IC 2.92 milliampere.
IC आपका आ रहा है 2.8 something. हाँ, 2.9 you can say. 2.8 something अभी.
IB equal to
और
4.5
VC
milliampere.
IB कितना आ रहा है?
4.5 milliampere.
no
नहीं
sir,
नहीं IB
2.92 into 10 to the power minus 5.
हाँ, so that means 28 microampere ना.
Yes sir.
28.43 microampere. Okay, that is 2.8 into 10 to the power minus 5. Correct. IB, so you just multiply by 100. Okay, 100. So 2.8 for IC will be your what? IC will be your 2.84 milliampere, isn't it? You multiply by 100. Okay, so this become 10 to the power 6. So 4 and you divide 10 to 2.8. Okay, 2.84 is your milliampere is your IC. Okay, so once you know the IC,
So VC is 3.75.
VC is coming. VC is 3.7 volt. Yes. Okay, so you know IC, now you can find VC. So VC is coming 3.7 volt approximately. Check it the question. Okay, IC saturation also you can check. Now let us do some problem which came in exam. This is R1, R2, okay, and then you have RE 1 kilo ohm, RC given 5 kilo ohm, beta given 50, VCC given 20 volt, okay, and this is your question, okay. So question, what they're asking, they say when R2 is disconnected, okay, when R2 is disconnected, if we remove this R2 in the circuit, then what will happen? Okay, so this is your base, so obviously this voltage is VB, this voltage is called VC, okay, where the collector, that's called VC, and this is VCE, and this voltage is your VE, okay. So he says when so this is on circuit, and in circuit you can calculate what is VB, VC and VE, okay. Now he says I'm removing R2. Once I remove R2, which is 20 kilo ohm, then what will happen? So they have given options, okay. They say number one, VB and VC increases, okay. Number two, they say both VB and VC decreases, both VB and VC decreases, okay. And third option says VB decreases but VC increases, okay. VB decreases but VC increases. And the fourth option, they say VB increases but VC decreases, okay. So question is very simple. You can do it in two ways, okay. One is you have to solve the circuit, okay. Solve the circuit means what? You have the voltage divider circuit, you calculate VThevenin. Either you do with approximation method, because here you have number is not important, so you can do with very simple with approximation method. Consider IB0, calculate VB, calculate voltage VB here, and then once you know the VB, you know this automatically, you know VE, you say this is 0.7, okay, because this number is not important, so you can do anything. So you can find VB here, okay. Once you know the VB, you can find VE. Once you know the VE, you can find this IE. Once you know the IE, you know the IC. You know IC, then you know this ICRC drop. So you can find what is voltage VC here, isn't it? You can easily calculate. Second time again to do second calculation, you remove this one, and then you have simple your collector bias feedback, okay. And again you do the calculation. Again you find what is VB here, okay. First you find what is IB here, and so voltage coming here, you're getting drop here, and you're getting some VB here, and then from VB, and you again you find this circuit, solve the circuit, and you find what is VC, and you compare what is happening. VB is decreasing, increasing, okay. So you can, one method is you have to solve the complete solution, and you have to check what exactly happening with R2 and without R2, okay. So first tell me whether this question is clear to you. What they are asking in the question? This question is clear to you or not? Tell me. Anyone? If this question is clear? So question, they are asking just if you remove this R2, then what will happen to potential this point and this point? With a decrease, increase, both decrease, one increase, other decrease. Okay, there are four options they are given. So just you solve the circuit and find the VB and find the VB and VC. Okay, so I'm giving you homework. Complete solution you have to check. Now I will do you solve this with my shortcut technique. Okay, so what is shortcut technique? just without solving, just by analyzing circuit, I will solve this one. Okay. Now, obviously, here, if I take approximation method, okay, this IB 0 here, so some current I is coming here, okay, and when I comes here, you will have some voltage drop here, and after getting voltage drop, you get some voltage here, okay, and this current go here when R2 is there. When you remove R2, that time what will happen? Once I remove this R2, now in the circuit, the current which is flowing, that is only IB, isn't it? And IB is very less compared to IE. So when less current is flowing here, the drop is less here. The drop is less here. That means now voltage here VC, here you have less drop, so automatically your VB increases. Okay, so your VB get increases when you remove your R2. Okay, now your VE, V is nothing, V is your VB minus VBE. So once your VB increases, automatically this is constant, your V also go increases, your V increases. Okay, once V increases, V is V, so IE is equals to your VE upon RE. So your IE increases. IE increases means your IC increases. IC increases means now here you have voltage, this drop get increased. So this IC increases, that means your drop across RC increases. The drop increases means now the remaining potential here VC, your VC get decreases. Okay, just by seeing, I can tell the option which is correct, the D option, that your VB increases, and your VC decreases. Okay, so I have done this
Sir,
by that method. हाँ, you can do
सर
solve.
एक और
हाँ
बात
बोलिए.
बता सकती हूँ?
हाँ बिल्कुल, क्यों नहीं बताएंगे एक बार. Okay, so when here a resistor is there, okay, then the current which is flowing in the circuit, that is I, and IB is 0. Okay, when we use the approximation method, I is flowing here. Okay, once I remove the circuit, so the more current is flowing here, that means we are getting more drop here. When you're getting more drop here, that means your voltage will be less. Now once you remove this circuit, okay, now no need to that approximation method, simply in this current which will flow now, that will be your IB. Okay, so once IB current is flowing, there's a drop here will be less, isn't it? The drop will be less here, that means your VB will increase, your VB will go, VB will increase. Okay, and once VB increases, okay, so V is equal to VB minus VB, this voltage is fixed, this is increasing to this increases. If this increases, your IE increases. If IE increases, your IC increases. Once IC यहाँ पे increase हो गया तो यहाँ drop भी बढ़ गया, ये voltage drop ज्यादा हो गया तो यहाँ कम बचा, इसका मतलब यह है your VC gets down, so VB increases and VC decreases. Okay, now this you have to, your homework, you have to check, you have to solve complete the circuit. Okay, this is homework you have to send me by solving with R2, without R2, solve the circuit and give me the value of VB and VC, VBE and VC, and we'll see what is happening. Okay, so this was your today's class, and we'll do some more exam problems. Okay, so now I will be in travel for 2 days. So your next class will be, I think today is your 8th, na? So maybe my next class will be on the 11th. 9, 10th I will be planned. So maybe 11th, from 11 onwards I will continue. So this Transistor, this will take 4 classes, and then OPM approximately 8 to 10 classes. Okay, so we will complete your syllabus before 25. Okay, and then we'll start digital whenever we get slot. So if you have a question, please ask. Any question? Okay, good. Then please send the homework. I'm stopping here.